Hello children, this video is about the areas of plane figures between parallel lines. In the first part of our video session we discussed two facts. The first one is how to find the area of a triangle and the area of a parallelogram. The second point is we discussed one theorem, that is parallelograms on the same base and the same pair of parallel lines are equal in area. So here we continue our lesson. There are two more theorems. So let us continue. If I draw two parallel lines, these are parallel lines. I take the line segment AB. This is my line segment. I take it as my base and I draw a parallelogram here. These two are parallel and these two are parallel. I name it as ABCD. And also I draw a triangle. Here I take it. Right. Now you know how to find the area of a parallelogram. Area of parallelogram ABCD, that is equal to base into altitude. Base into altitude. I take my perpendicular distance in between these two lines as h. So that is the perpendicular height. That is the perpendicular height of this parallelogram. You know the perpendicular distance at everywhere in between these two parallel lines are same. Therefore, that is h. And I take this AB length as A. Then you can say that is A into h. Similarly, you can say area of triangle, what is ABE, that is equal half into base into altitude. Our base is A, altitude here h, here h, so our altitude is h, that is half AH. Half AH. Can you see there is a relationship between these two, 1 and 2? So we can see area of triangle ABE equal half into, instead of this h you can put area of parallelogram ABCD. Area of parallelogram ABCD. So this is our second theorem. This is our second theorem. So using this theorem you can do, so this is our second theorem, that is if a triangle and a parallelogram lie on the same base and between two parallel lines, then the area of a triangle is exactly half the area of a parallelogram. That is our second theorem. Again, if a triangle and a parallelogram lie on the same base and between same pair of parallel lines, then the area of a triangle is exactly half of the area of a parallelogram. So using this theorem we can do some problems. The problems are given in your textbook in exercise 8.3. We will move to that. Here in your textbook you can see there are some problems. If you consider first one, here the figure is this. The area of a parallelogram ABCD in the figure is 50 square centimeter. ABCD is 50 square centimeter. So in the first part they ask you to do what is the area of a triangle PDC. Where is PDC? PDC. So you can see the area of ABCD is given as 50 square centimeters. We need to find the area of PDC. Can you see these two triangle and parallelogram lie on the same base DC and between the same pair of parallel lines? Then using our theorem we can say the area of a triangle PCD equal half of the area of a parallelogram ABCD. So exercise 8.3 first part you can say area of triangle PDC equal half into area of parallelogram ABCD. How? Using the theorem. So you can say half into, this is given as 50 square centimeters. So after simplifying you can take 25 square centimeters. The second one, what is the area of a triangle DCQ? Where is DCQ? Area of triangle DCQ, that is half into DCQ. Half into base is DC. The altitude is the perpendicular distance from Q to this line. That is same as this. If I take the altitude of this triangle as h, that is the same as for the triangle DCQ. So I take the altitude as h here. Then if you consider this triangle PDC, area of triangle PDC also equal to this y. That is equal to half into base is DC and area of PDC, that is half into base into altitude. These two are equal, so you can take the area of triangle DCQ as 25 square centimeters. Second and third problem you can do. If you move to the next page, there are few problems. So if you consider fourth problem, here there is a figure. P is any point on the side AB of the parallelogram, and we have to prove this one. Area of APD, where is APD? APD plus area of BPC equal area of DPC. Fourth problem, you know the area of this triangle PDC equal area of triangle PDC equal half times area of parallelogram ABCD. That means the half of this parallelogram is equal to this one, this triangle. Half of this parallelogram is equal to this triangle using the theorem. right? So the other half should be equal to the sum of these two. So the other half, I take half of area of parallelogram ABCD. The other half should be equal to the sum of these two, the rest. Area of APD triangle plus area of BBC triangle. So the one half is equal to this one, the other half is equal to this one. You know the half of this parallelogram halves are equal. Therefore, you can equate these two. Therefore, you can say area of triangle PDC equal area of triangle APD and area of triangle BBC. This is what you have to prove. And I think you can try other two, 5 and 6. Now I will try to do the 7th one. Seventh one, this one. Here O is the midpoint of the side BC. You have to prove. First part, 7th one, first part. The area of triangle BOX equal, where is BOX? BOX equal OCY. We have to show that areas are equal. The method is we have to show, if we can show that these two triangles are congruent, then the corresponding elements are equal. Then we can say area of these two triangles are equal. So then we will try to congruent these two triangles. So consider triangle OXP and triangle OCY. So it is given that these two sides are equal. The reason is O is a midpoint. BO equal OC. That is given. And also you know this angle and this angle are equal. Those are vertically opposite angles. So you can say BOX angle equal COY angle. The reason is vertically opposite angles. Similarly, you know these two angles are alternate angles. So XPO equal to OCY. Those are alternate angles. Therefore, you can say triangle OXB congruent to triangle OCY. The reason is under which case? Angle, side case. Therefore, area of triangle OXB equal area of triangle OCY. First part is okay. The second part, the area of trapezium AXYD equal area of parallelogram ABCD. That is AXYD, AXYD, that is AXYD equal the area of parallelogram ABCD. Yeah. Can you see AXYD is equal to this one, that is clearly see. So we will see. So you can say area of trapezium. AXYD equal. So you can say that is equal. If you consider this pentagon, AXOCD, AXOC, that is a pentagon. If you add the area of this triangle into this pentagon, you get the area of AXYD. So you can say area of AXOCD plus area of triangle OCY, pentagon and triangle. Then it is equal to trapezium AXY. So you know the area of this triangle equal to this one. Instead of this part, we can write that one. So again, write the area of AXOCD plus, instead of this one, I write area of triangle XBO. We proved that in part 1, right? Therefore, area of this one plus this one means area of parallelogram ABCD. So we proved the second part. Third part, the area of a trapezium AXYD is twice the area of ADC. So you know where is ADO? ADO, yeah. Can you see this ADO triangle and ABCD parallelograms are lie on the same base AD and between the same pair of parallel lines. Therefore, you know area of triangle AOD equal half into half times half of area of parallelogram ABCD using theorem. That means area of parallelogram ABCD can multiply both sides by 2, then 2 times area of triangle AOD. So I label this as 1, this as 2. This is our third part using 1 and 2. You can say area of trapezium AXYZ equal to, here instead of this one I can write this 2 times area of triangle AOD. So we proved the result, that is twice the area of ADO. That means 2 times area of the triangle AOD. In the first problem, we showed that the area of BDC and DCQ are equal. That is our next theorem. That is, if two parallel lines are there, and I take my base as CB, and I consider one triangle, that is ABC, the other one is ABD. Then you know the perpendicular distance between two parallel lines is equal at everywhere. Therefore, the perpendicular height is h, that is h at everywhere. Then here, that is h. If you consider here, that is also h. Then you can easily see that area of triangle APD equal half into base is AB into h. Area of triangle APC equal half into base is AB, altitude is h. So you can see these two are equal. So the conclusion is area of triangle APD equal area of triangle ABC. This is our last theorem. That is triangles on the same base. Triangles on the same base and between same pair of parallel lines. And between same pair of parallel lines are equal in area. Like the first theorem. Parallelograms on the same base and between the same pair of parallel lines are equal in area, same as that is valid for triangles the same way. So if we move to our problems, to our exercise, for exercise 8.4, first one, area of a triangle ABP. Where is ABP? ABP, which lies between parallel lines AB and CD. In the figure is 25 square centimeters. That means the area of ABP is 25 square centimeters. What is the area of a triangle ABC? So it is clear. Area of triangle ABC equal 25 square centimeters. The reason you can write the theorem. What is the theorem? Triangles with the same base and between the same pair of parallel lines, are equal in area. That is our theorem. So the second part, if the area of a triangle ABX is 10 square centimeter, ABX is 10 square centimeter, what is the area of triangle ACX? ACX, that is easy. You know, this part is given, that is 10, the whole one is 25. Then what you have to do? They ask us to find the area of this one. So you know the whole thing is 25, this part is 10, then this is 50. You have to subtract 10 from 25. So area of triangle ACX equal, I'll write it as a sentence, area of triangle ABC minus area of triangle ABX. This is we found in our first part, that is 25. This is given ABX. I think it is given as ABX is 10. Then the answer is 15 square centimeters. Those are easy. Third part. Explain with reasons